Now in this lesson, we want to look at text clustering using the SAS text miner cluster node. Let's do a quick revision. Now, clustering are groups of objects such that those within the groups, the same group, the objects are similar, and those who objects that are in different groups, they are very dissimilar. Now, this clustering can be quite subjective. It depends on what similarity function that we define. So, for example, in this case, we define the function that's just color attribute, and probably we have only two colors, right? So we have two clusters, and then if we define the function as color and shape, then we probably get four clusters. So two of the attributes are being used to differentiate different groups. Now, if we use the weight, then we will get different groups, three clusters with different objects in each cluster. Now, just a few points to note. Now, the number of clusters depends really on the attribute or the combination, the attribute that we use, okay, or what we call similarity function. Now, an object can only be in one cluster. So, for example, in the cluster node, the terms in the term by document matrix, one term can only be in one cluster, and the clusters are mutually exclusive, right? Now, take note that clustering is a data mining technique that is normally used for exploratory purpose. That means when we receive a data after you have cleansed it, we just normally run a cluster node to discover its natural grouping, right? We don't really predefine or pre-label any classification, and that's why it's called unsupervised learning. Now in SAS, okay, after we're done all the text parsing, text filtering, all the necessary transformation, the data are now ready for data mining. So today we are just looking at, or last week and today we are just looking at clustering. Now today I want to look at how we can do clustering in SAS. So take note that the cluster node is run after the filter node. Now if you click on the cluster node on the property panel, you will see that you can define the SVD resolution. Now what is SVD? I assume that you have covered the notes and the video early on. And then you have the cluster algorithm. Now in SAS, we use EM and hierarchical. Now which one is better? Actually, they are just different approach, right? So the important property attribute in clustering node is actually the clustering algorithm and the resolution, the SDV resolution that we use. So what we do is that in this particular example, we have different models, right? As you can see, I have 6 models here. Now, the first 3 models run using the EM, but with different resolution, low, medium, and high. The next 3 clustering nodes, I use the hierarchical algorithm, right, running on low, high, and medium, okay, resolution. So when you run a clustering node, this is right. This is the results that you get, the output. Now over here, there are quite a few windows here, right? This window give you the idea, the, the number of clusters, right? The number of clusters and the percentage of the cluster. Now each of the clusters are defined by the descriptive terms, right? The descriptive terms by default is 25 terms. It gives us the idea of the theme of each cluster. So in this case, there are 6, right? Now in this window here, it shows us the distance between clusters. Now this is a very important window. Remember, if we are saying that clusters must be distinct, so the distinctiveness is demonstrated by the distance between any two clusters, right? Now over here is the clusters RMS. Now RMS is the root mean square. Alright, it is the measure of error for each cluster. Okay. Now when you click on any of the clusters, for example, you click on 2, you can see the highlight in each of these window here. So the important window are 1, 2, 3, and 4 here. Right? So we'll look at this in more detail. So just now I mentioned that we have 6 models here. So the question is, which of the cluster model is optimum? Okay, that's what we are examining now. So this is the comparison of cluster frequency. That means this part here for all the 6 models. Now as you can see here that different model give you different output, but more or less they give you somewhere between 5 to 7 clusters. The top part here is using the EM. Now you can see on the EM there is this cluster here that is very, very small. Probably if you look at the model, the description terms, it refers to this, right? You can see here. Okay, the hierarchical below 3 is the hierarchical using hierarchical algorithm with different SVD. Okay, now if you want to know the exact percentage, you go to the descriptive terms. They can tell you, yeah, the numbers here. Now the frequency number here tells us the number of terms that goes into each cluster that make up this cluster. All right, and this is a percentage. Now the descriptive terms here are actually very important terms. That means they are terms that carries a very high weightage. Remember we talked about the global weight. So these are terms that are important which has high global weight, right? And they are used for describing the themes of the cluster. So there are 6 clusters here. How do we know which one is suitable, right, or the best for our analysis? Now, first of all, remember the cluster. We look at the distance between the cluster. Okay. Now, remember we say that objects within the cluster must be similar. Okay, object between the clusters must be very, very dissimilar. So in terms of looking visually at the distance between a cluster, okay, the cluster must be very distinct in terms of their distance. Okay, so you can see, for example, in this first one, using EMS, SVD, low SVD, you find that the clusters are quite distinct. They are quite far apart. Okay, so actually, if you look at all the 6 models, they are actually seems to be quite distinctive. All right, then how do we differentiate them? All right, how do we choose them? So the next thing that we want to look at is look at the error. Okay, the root mean square of each cluster. Okay, let's look at this one here. Now the root mean square is a measure of the variance, the error, when each cluster is being formed. So the guideline is that the root mean square of each cluster should be below uh, 0.1, right? As little as possible. So if you look at closely, okay, you have, if I take the first cluster which is has low SVD with EM, you find that some of the clusters are being formed with RMS above 0.1, all right, 0.1. So if we examine closely, if we look at it, we can see that we try to look for clusters that's below, most of the RMS is below 0.01. So probably you look at uh, this cluster EM with SVD high. Okay, you can see that the most of the clusters have errors below 0.09, sorry, 0.1, right? 0.1. So is this one, right? So is the hierarchy with high SVD. Now the rest, you can see that this one, there are some that goes above 0.1 uh, and so on. And this one is, yeah, there are some. So if you look at, if you're using the RMS to compare, you find that actually it's between this one, okay, EM with high SVD and hierarchy with high SVD, okay, because most of the RMS values fall below 0.1. Okay, so we have tentatively select this cluster 6, right, based on uh, the RMS. The next thing is, okay, we want to examine the selected cluster, which is 6, cluster 6, further. Now, if we look at if we go back to the descriptive terms of 6, which is this one, okay, you can see that these are the keywords. Now, what you can do is, for example, I take this model, okay, this model. Uh, sorry, this is 6 model. This model. Now, the keywords are lenses and lens and so on. Now, so this is probably one of the themes that is being mentioned by the documents, right? Remember, the corpus of documents is all the camera reviews. Okay, so we can look, we, we can actually go back to uh, the filter viewer, right? Filter viewer is in the filter node, and actually look at some of the documents related to okay, in this case I use the word battery because battery also occurs very often in the clusters. Okay, uh, so if I search for the word here, for in this case battery, or I can search for lens. Okay, the original documents will appear in this window, right? Document windows, and you can see all those original document that describe about battery. Okay, so if you type lens, you will be able to see the lens, all the documents talking about the lens. Now over here, if you do a search, you click on here, you open up this window. You can also search for, in this case, a battery, and then yeah, look at the weight of the battery. Okay, so it allows us to, this filter viewer allows us to go back to look at the original documents that talks about a particular theme, okay, in the cluster. Now, what we can do next is really to find out a bit more insight through the concept viewer. All right. Now, concept viewer, if you, for example, it can be, uh, you can actually right click any of the terms here, okay, for concept viewer, and you will get sorry, yeah, you will get the concept viewer here. Okay, for example, I click on the word lens, right? It tells me uh, the code, the terms that are associated with lens. Remember, concept links tell us about the co-occurrence. Okay, so it give me some insight. For example, lens, if I expand the lens, okay, I get the term sharp. So if I expand sharp, it give me the terms image and so on. So for me, I can roughly get the insight that, yeah, the feedback from one of the teams in the cluster 6 is about the image quality, and the quality is actually good, right? So this is to give us a further insight to a particular team that we saw in cluster 6, okay, sorry, in model 6. So in summary, let me summarize the approach. So first of all, you run the cluster node with all the default setting, the algorithm, the SVD resolution, and then you compare the distance between the clusters. Okay, the distance must be distinct. Okay, and then we also compare the root mean square of each models and select the best model. Okay, after we select the best model, we look at the concept links of the selected model, and then from the concept link try to analyze, get more insight relating to key terms. Now we can also look at the documents window to examine the original documents of the key terms. This will give us further insight and confirmation of the themes there is in the themes of the selected cluster. Okay, thank you.